Question 1. The triple points of neon and carbon dioxide are 24.57 Kelvin and 216.55 Kelvin respectively. Express these temperatures on the Celsius and Fahrenheit scales. Okay, the relation between Celsius scale and Kelvin scale, both the temperatures are given in Kelvin scale. So we can have Tc, the temperature in Celsius scale, equal to Tk minus temperature in Kelvin scale 273.15. So you can substitute the values of 24.57 and 216.55 in the place of Tk. You will get the values of temperatures in Celsius scale. Now, next, the same we have to calculate in Fahrenheit scale also. We have the formula Tf minus 32 by 180 is equal to Tc minus 0 by 100. Simplify this equation. You will get Tf, temperature in Fahrenheit scale, is equal to 9 Tc divided by 5 plus 32. This formula can be directly used for conversion between Fahrenheit scale and Celsius scale. So substitute the values of Tc which you have calculated in previous case. You can find the values in Fahrenheit scale. Now, question 2. Two absolute scales A and B have triple points of water defined to be 200A and 350B. What is the relation between TA and TB? TA and TB are the triple points, okay, of the measurements in A and B. So here we have a 200A, that is the triple point in scale A, is equal to 350B. 350B is equal to 273.16 Kelvin. That is a triple point of water in Kelvin scale, and all three are absolute scales. Therefore, triple points are equal in these scales. So we can rearrange this equation and we can find what is the size of 1 unit in scale A. So here 1A is equal to 273.16 divided by 200 Kelvin, and 1B is equal to 273.16 divided by 350 Kelvin. So this is the size of 1 unit in A and B. Now, TA and TB can be considered as the triple points. Then the measurements we can take like this. We have 273.16 divided by 200 is the size of 1 unit in scale A into triple point A, that is TA, is equal to the size of 1 unit of B is 273.16 divided by 350, exercise of 1 unit into TB. Measurement in the scale B, temperature in scale B. Now, simplify this equation and you can find the value of TA by TB. TA by TB. So you will get the relation between TA and TB. Then question 3. The electrical resistance in ohms of a certain thermometer varies with the temperature according to the relation R is equal to R naught into 1 plus alpha T minus T naught. Okay. So you know the resistance of a conductor depends on temperature. When the resistance and the temperature increases, its resistance also increases. And the relation between temperature and resistance is given in the formula. Now the values of temperature, resistance, etc. are given there. So we have the temperature 273.16 Kelvin that we can take as T naught, and the corresponding resistance is 101.6 ohm taken as R naught. Then next, another value of resistance is given, that is 165.5 ohm at a melting point of lead 600.5 Kelvin, that we can take as T and R. T and R. Now, what is the temperature when the resistance is 123.4 ohm, which we can take as R dash. R dash is equal to 123.4 ohm. Then, if that is the value of R dash, what is the corresponding temperature T dash? That is what you need to calculate. The formula is already given in the question. Now, what we can do here, we have actually 3 sets of values: T naught and R naught, T and R, now R dash and T dash. 3 sets are there. Equations can be constructed here. The first equation, we can take the one given there, that is, we have R is equal to R naught into R is equal to R naught into 1 plus alpha into T minus T naught. Now, from this equation, so this is the relation connecting the first two sets of values. From this equation, you can find the value of alpha. Alpha is equal to R minus R naught divided by R naught into T minus T naught. R naught into T minus T naught. So you'll get the value of alpha. It's not necessary you need to calculate the value of alpha. If you want to calculate, you can substitute in the next equation. That is, R dash is equal to R naught into, again, 1 plus alpha T dash minus T naught. This is the second equation. So what can be done in the first, using the first formula, you can find the calculate the value of alpha, substitute in the second formula so that you can find the value of T dash. Otherwise, you can follow this method also. You can find the value of T dash minus T naught. T dash minus T naught is equal to, you can see, R dash minus R naught divided by alpha into R naught. Alpha into R naught. Now, if you calculate the value of alpha in the first step, we can substitute the value of alpha, R dash and R naught. so that T dash minus T naught can be calculated. From there, T dash can be calculated. Or this formula for alpha can be substituted in this equation. Then simplify the equation. You will get T dash minus T naught is equal to R dash minus R naught divided by R minus R naught into T minus T naught. So that you can use this formula. You use this formula with one step, substitute these values. Directly you will get the value of T dash minus T naught. Once you get the value of T dash minus T naught, then the value of T dash can be calculated. Then question 4. Answer the following. The triple point of water is a standard fixed point in modern thermometry. Why? Because triple point is a unique point having specified temperature and pressure. Okay, so as it is a unique, a particular point, particular value. So triple point is fixed always. So it can be considered as a standard value. Then what is wrong in taking the melting point of ice and the boiling point of water as standard fixed points? Okay, the problem is melting point and boiling point depends on pressure. So they are not fixed values. That is why it's not possible to take those two values. Part B. There were two fixed points in the original Celsius scale and as mentioned above, which were assigned the number 0 degrees Celsius and 100 degrees Celsius respectively. That is the ice point and steam point. Then, on the absolute scale, one of the fixed points is the triple point of water, which on the Kelvin absolute scale is assigned the number 273.16 Kelvin. What is the other fixed point in this scale? So here, when you design a thermometer, you needed two fixed points as it is mentioned in the first part of the question for Celsius scale. So what are the two fixed points in the Kelvin scale? That's the question. One of the fixed points is the triple point of water, that is 273.16 Kelvin. And what is the other fixed point? The other fixed point, which is totally independent of all other material and external properties, is found to be absolute zero, which is 0 Kelvin. That is the second fixed point. Absolute zero is the second fixed point. Absolute zero is taken as 0 Kelvin. Then part C, the absolute temperature in Kelvin scale. Okay, T is related to temperature Tc on the Celsius scale. The relation between measurements in Celsius scale and absolute scale is given. Then why do we have 273.15 in this relation and not 273.16? 273.16 is the triple point of water. It is not the absolute zero. Absolute zero is 273.15. That is the reason we have taken 273.15. Then part D. What is the temperature of the triple point of water on an absolute scale whose unit interval size is equal to that of Fahrenheit scale? Okay, we have a new absolute scale of temperature. And what is the speciality of that new scale? The new scale whose interval size is equal to Fahrenheit scale. In Fahrenheit scale, the steam point and ice point are separated by 180 equal divisions. Therefore, we can say in the new scale, okay, let us call the new scale as X. In the new scale, between steam point and ice point, we have 180 equal divisions are there because we have 180 equal divisions between steam point and ice point in the Fahrenheit scale, and that is equal to 100 Kelvin, because between steam point and ice point there are 100 divisions in Kelvin scale. Therefore, we can say 180 divisions in the new absolute scale is equal to 100 division in the Kelvin scale, or 1 Kelvin is equal to 1 Kelvin is equal to 180 divided by 100 in the new scale x. And you are asked to calculate triple point. So triple point in Kelvin scale is 273.16 is the triple point in the Kelvin scale. So, and we know 1 Kelvin is 180 by 100 x. So then how much will be 273.16 Kelvin? 273.16 Kelvin will be 273.16 into 180 divided by 100x. So simplify, you will get the value of triple point in the new scale x. Next, question 5. Two ideal gas thermometers A and B use oxygen and hydrogen respectively. They are ideal gas thermometers. The following observations are made. Triple point of water. At triple point of water, pressure of thermometer A, which we can call as PTR, and here for thermometer B, okay, that also can be taken as PTR, pressure at a triple point. Then normal melting point, the pressure we can take as P here, here also P. And what is the absolute temperature at normal melting point? And triple point, we know the triple point TR is equal to 273.16 Kelvin is the triple point. Now here we apply the law of volume, that is P proportional to T, or P by T equal to constant when volume is a constant. P by T is a constant. So accordingly, we can take the equation here. P by T, that is pressure and temperature at a normal melting point, is equal to PTR, pressure at a triple point divided by triple point. So P by T is a constant. P by T is a constant means P1 by T1 is equal to P2 by T2. This is according to gas law. So that we can apply here. P by T is equal to, means the ratio of pressure and temperature at a normal melting point is equal to PTR divided by TR, the ratio of the same at a triple point. So now what are the quantities given there? P is there, PTR is there, TR we know, so that T can be calculated. And using this formula, you need to calculate the value of T for two cases. One is for hydrogen and other one for oxygen. Okay. Now, Part B. What do you think is the reason behind the slight difference in answers of thermometers A and B? Actually, you are measuring the temperature using two thermometers, but when you complete the calculations, you can see there is a small difference in the measurement, which is not expected. So, what is the reason for that? Okay, reason for the discrepancy in the measurement. So, we can explain the discrepancy. As the problem mentioned, they are ideal gas thermometers, but we know oxygen and hydrogen, they are not ideal gases, they are only real gases. So we cannot take them as exactly the ideal gases, they are real gases. So there is a small difference in the measurement. We cannot apply 100% ideal conditions in these two cases. Now come to question 6. A steel tape 1 meter long is correctly calibrated for a temperature of 27 degrees Celsius. The length of the steel rod measured by this tape is found to be 63 centimeter. We can take as L1, 63 centimeter. Then on a hot day when the temperature is 45 degree Celsius. Temperature is 45 degree Celsius. What is the actual length of the steel rod on that day? What is the actual length of the steel rod? What is the length of the same steel rod on a day when temperature is 27 degree Celsius? Okay, so here we can use the formula L1 is equal to L naught into 1 plus alpha delta T. 1 plus alpha delta T. So you get this equation, we have delta L is equal to alpha L delta T. Okay, so this formula you have studied already. Delta L is equal to alpha L delta T. Then delta L can be considered as L1 minus L, change in length, is equal to alpha L delta T, and find the value of L1 from this formula. So you will get this equation. Now substitute the values there, you will get the answer. The temperature at 45 degrees Celsius. Delta T you have to take as 45 minus 27 is delta T. So that the new length L can be calculated. And what is the actual length of the steel rod on that tape? Okay, which you got the answer. Then what is the length of the same steel rod on the day when the temperature is 27 degrees Celsius? You see there the tape is calibrated when temperature is 27 degrees Celsius. So if the temperature is 27 degrees Celsius, then you will get the exact length. That is 63 you will get. Otherwise, you can see because of the extension, it will be slightly greater than 63. Now, come to question 7. A larger steel wheel is to be fitted onto a shaft of same material. At 27 degrees Celsius, the outer diameter of the shaft is 8.7 centimeter and the diameter of the central hole in the wheel is 8.69 centimeter. The shaft is cooled using dry ice. At what temperature of the shaft does the wheel slip on the shaft? Okay, so I think the question is clear. So we have just like we can take a block like this. Now there is a hole here, and the diameter of that hole is given 8.69. This diameter is 8.69 centimeter. Now we have a shaft to be fixed here in this hole. We have to fix this shaft, but its diameter is 8.7 centimeter, 70 centimeter. So as the size of the shaft is greater than the diameter of the hole, you cannot insert the shaft into the hole. So if you want to insert the shaft into the hole, then its diameter has to be decreased by 0.01 centimeter, which can be taken as delta L. So we can consider as it is the decrease, then so minus delta L is equal to 0.01 centimeter, and its original size L is equal to 8.70 centimeter. So we can use the formula minus delta L is equal to L alpha delta T. Thermal expansion formula can be used. Then substitute the values, then find the value of, from this equation, find the value of delta T. Once you get the value of delta T, you can have delta T is equal to T minus 27. Substitute the value of delta T there, then find the value of T. Next, question 8. A hole is drilled in a copper sheet. The diameter of the hole is 4.24 centimeter at 27 degrees Celsius. What is the change in diameter of the hole when the sheet is heated to 227 degrees Celsius? Coefficient of linear expansion of the copper is given. So you see, like this, we have a sheet, the hole. Then when you heat, you can see the diameter of the hole will increase. So there is a linear expansion we can consider there for the diameter. Okay, so accordingly, we can apply the formula for linear expansion again. Delta L is equal to L alpha delta T. Delta L is equal to L alpha delta T. Alpha is given. The original length is given, diameter is 4.24 centimeter is the value of L. Then delta T you can calculate, that is 227 minus 27, so that the value of delta L can be calculated. Question 9. A brass wire 1.8 meter long at 27 degrees Celsius is held down with a little tension between two rigid supports. If the wire is cooled to a temperature of minus 39 degrees Celsius, what is the tension developed in the wire if its diameter is 2 millimeter? Coefficient of linear expansion and Young's modulus. So this is a case of thermal stress, and we have seen the formula for thermal stress, the force formula. F is equal to Y A alpha delta T. Already this equation we have seen in the theory for thermal stress. F is equal to Y A alpha delta T. All the values are given. So the tension in the wire can be calculated. Question 10. A brass rod of length 50 centimeter and diameter 3 mm is joined to a steel rod of the same length and diameter. What is the change in length of the combined rod at 250 degree Celsius? If the original lengths are at 40 degrees Celsius. So change in temperature delta T can be calculated. Okay, this delta T is 210 degrees Celsius. Now length and diameters are given. So you can calculate, you can use the formula delta L is equal to L alpha delta T for linear expansion. Then find the value of brass rods can calculate, delta P can be calculated, then plus the second one is steel rod. So delta S, both you can calculate separately so that you will get the total extension delta L total. Okay. Now the second part of the question, the ends of the rod is there a thermal stress developed at the junction? The ends of the rods are free to expand, which means the rods are now like this. So here you have the junction. So one is brass rod and the second one is steel rod. So we know that the thermal expansion will be there, so that length increases. So the question is at the junction, is there any stress due to expansion? Any force, pulling force there? Okay, actually there is no force at the junction because these two ends are free to expand. So just the expansion is going on, that's only. So there is no possibility of having an additional stress acting on this junction as the other ends are free to expand. Question 11. The coefficient of volume expansion of glycerin, gamma or alpha V is given. Okay, can be taken as gamma or alpha V. What is the fractional change in density for a 30 degree Celsius rise in temperature? Delta T is 30 degree Celsius. Okay, so we can calculate. First of all, we can use the formula V dash is equal to V into 1 plus gamma delta T. Again, you will get this formula. Delta V is equal to V gamma delta T. Okay. Now substitute the values of gamma and delta T and find the value of V dash. V dash you will get as 1.0147 V. That means V dash we get in terms of V. Now we know the density formula rho is equal to mass by volume. Rho is equal to mass by volume. So the new density rho dash is equal to mass remains same divided by V dash. You can substitute the value of V dash there. You will get M divided by 1.0147 V. Again you will get M by V is rho only. So you will get rho divided by 1.0147. We are taking more decimal places because the variation will be very small. That's the reason. Okay. So here you will get the value of rho dash in terms of rho. So when you calculate, you will get around 0.9855 rho. So you will get rho dash in terms of rho now. And from this equation, you can calculate the fractional change, that is rho dash minus rho divided by rho. Substitute the values and find the value of fractional change. Then next, question 12. A 10 kilogram drilling machine is used to drill a hole in a small aluminium block of mass 8 kilogram. How much is the rise in temperature of the block in 2.5 minutes, assuming 50% of power is used up in heating the machine itself or lost to the surroundings. Specific heat of aluminum is given. Okay, now the power is given and time is also given. And here you have to see energy is equal to power into time. Energy is equal to power into time. And this 50% of energy, 50% of this energy is used for heating. 50% of energy is used for heating. Therefore, we can say 50% of energy, that is power into time, is equal to ms delta T, heat absorbed for change in temperature. Q is equal to ms delta T. So if Q is the heat absorbed, m is the mass, S is the specific heat, then delta T is the change in temperature. So we use this formula. Then here, once you get the once you substitute the values, you can find the change in temperature delta T can be calculated. So I told you what is the rise in temperature, that's a question. But here, you substitute the value, here you need to take one point. That is, specific heat is given joule per gram per Kelvin. But all other quantities you need to substitute in the formula in SI unit. Therefore, this quantity also you need to change. The gram is in denominator per gram. So gram you have to convert into kilogram. When it comes into numerator, when it becomes 10 power plus 3. That means 0.91 into 10 power 3 joule per kilogram per Kelvin should be the value substituted in the formula to calculate delta T. Then question 13. Copper block of mass 2.5 kilogram is heated in a furnace to a temperature of 500 degrees Celsius and then placed on a large ice block. What is the maximum amount of ice that can melt? Specific heat of copper is given, latent heat of fusion of water is given. Okay. So here, what is the use of the heat absorbed? The heat absorbed is used to melt the ice. So, which means we have the copper block. The copper block will lose the heat energy while ice will absorb the heat energy to be melted. So heat lost by the copper Q is equal to mass of copper into specific heat of copper into change in temperature of copper. Okay, the change in temperature is here, it is kept in contact with the ice. Ice temperature is 0 degrees Celsius. Copper block has a temperature 500 degrees Celsius. Therefore, change in temperature will be 500 minus 0, that is 500. And what is the use of this heat energy? The same amount of heat energy, heat lost is equal to heat gained is equal to Q is equal to used for phase change, melting. So you have mass of ice melts into latent heat, Q is equal to ml. Now equate, you have NCSC delta T is equal to mass of ice melts into L. So that Mi can be found. In this question also, you have to note clearly here specific heat and latent heat are given in the unit per gram. You have to multiply both by 10 power plus 3 to convert per kilogram. Now, question 49, an experiment on the specific heat of metal. A 0.2 kilogram block of the metal at 150 degrees Celsius is dropped in a copper calorimeter of water equivalent 0.025 kilogram, containing 150 centimeter cube of water at 27 degrees Celsius. The final temperature is 40 degrees Celsius. Compute the specific heat of the metal. Conditions are given. Okay, so here also we can use the principle of calorimetry. Heat lost by the metal is equal to the heat gained by the water. So what is the equation for heat lost by the metal? Q is equal to heat lost by the metal is equal to, okay, it is mass of the metal into specific heat of the metal into change in temperature delta T. And what is the value of delta T in this case? You can see delta T is equal to delta T is equal to, it was at a temperature 150 degrees Celsius. Now the final temperature settled is 40 degrees Celsius. So it is 110 degree Celsius. Now water will absorb this heat. So what do you have to do? Here water, the heat absorbed by the water, Q is equal to, so we have to consider the mass of water plus mass of water equivalent of the calorimeter together into specific heat of water into change in temperature of water delta T. And what is the value of delta T here? Delta T is equal to, we can see there water is at 27 degrees Celsius and finally it is settled at 40 degrees Celsius. Therefore, change in temperature in the case of water is 40 minus 27 degree Celsius. Now, as I mentioned, you can apply heat lost is equal to heat gained, and the specific heat of water SW, we have to approximate 4.2 into 10 power 3 joule per kilogram per Kelvin. Joule per kilogram per Kelvin. Now, you can equate these two formula because heat lost is equal to heat gained, apply principle of calorimetry, and the specific heat of the metal can be calculated. Now, next question 80. A child running a temperature of 101 degree Fahrenheit is equivalent 95 in medicine that lowers fever, which causes an increase in the rate of evaporation of sweat from his body. If the fever is brought down to 98 degree Fahrenheit in 20 minutes, what is the average rate of extra evaporation caused by the drug? Assume the evaporation mechanism to be the only way by which heat is lost. The mass of the child is 30 kilogram. The specific heat of human body is approximately same as that of water, and latent heat of evaporation of water at that temperature is about 580 calorie per gram. Okay. So here, first of all, we can calculate the data is given. First of all, we can calculate the change in temperature of the child. The change in temperature is 3 degree Fahrenheit. Delta T is equal to 3 degree Fahrenheit. Let us convert into Celsius is equal to 5 by 9 into 3 degree Celsius is the change in temperature. Either we can say degree Celsius or as it is a difference in temperature, it is Kelvin also. Okay. So here that plus 32 you need not take, because when you take it two temperatures, that plus 32 will be, when you take a difference in temperature, that 32 will be cancelled there. So this is enough. Okay, now next we can calculate the heat lost by the child. Okay, so Q is equal to mass of the child, specific heat of the body, which is equal to specific heat of water, into delta T, equal to the mass of the child. You can take 3 into 10 power 3 gram into specific heat of water is 1 according to the definition in CGS system. Okay, so because 1 calorie is defined as the heat required to rise the temperature by 1 degree Celsius. So it will be 1 only. Into change in temperature in degree Celsius, we have already calculated. Okay, that is 5 by 3. So this is 30 into 10 power 3. So simplify, you will get around 50,000 calorie, which is calculated in calorie, because values we have substituted in gram, specific heat also in calorie, etc. Okay, now 50,000 calorie of heat is used, and for 1 gram, 1 gram of water, you have to use 580 calorie of heat for evaporation. For 1 gram, 580 calorie. So here you have used 50,000 calorie. What is the mass of water? Mass of water evaporated is equal to, we have 50,000, that is the total calorie used divided by 580 calorie per gram. So you will get the answer in gram, mass of water used. Now the question is not the mass of water evaporated. The question is, what is the average rate of extra evaporation? Rate of evaporation. Okay. So this much MW amount of water is evaporated in 20 minutes. So what is the rate of evaporation? How can you calculate the rate of evaporation? The rate of evaporation is equal to MW gram of water is evaporated in 20 minutes. So rate of evaporation per minute is equal to MW divided by 20. So final answer you will get in gram per minute. Then next question 90. A thermocol ice box is a cheap and efficient method for storing small quantities of food in summer in particular. A cubical ice box of size 30 cm has a thickness of 5 cm. If 4 kg of ice is put in the box, estimate the amount of ice remaining after 6 hours. The outside temperature is 45 degrees Celsius and the coefficient of thermal expansion. The coefficient of thermal conductivity of the thermocol is 0.01 joule per second per meter per Kelvin. Then heat of fusion of water is also given. Okay. So here, what is the concept? We have the thermocol box, closed thermocol